This is a revised version of practice problem number 5 from lesson 2, Keeping the Equation Balanced, and unit 4, Linear Equations and Linear Systems. In problem number 5, you're given these two parallel lines, and you're asked to write an equation for each. And this problem comes from unit 3, lesson 8. Well, you're told that these two lines are parallel. So that means that they have the same slope. And the slope is a measure of how much each line is changing in the vertical direction, how much the line is changing in the horizontal direction. So to calculate the slope, I'm going to choose a point right here, 4, 0, and a point up here, 9, 4. And I'm choosing this point that's on the x-axis on purpose because this slope triangle is not going to move vertically at all. It's not going to move up and down because it's already on the x-axis. And so what's going to happen is when you calculate the slope, this slope triangle is going to slide down to the origin, down to here. It's actually going to match the slope triangle on this second line right here. So to calculate that slope, it's the change in the vertical direction. So this 4 minus 0. So notice it's not moving at all vertically. It's staying right here. This is 4 units along the y-axis for this point and 0 units along the y-axis for this point. So 4 minus 0 is 4. And the change in the horizontal direction is these 9 units. We're going to get rid of these 4 units right here. So we're going to subtract those 4 units away. And the slope triangle is going to slide down to right here, down to this origin. So this length then, along the x-axis, is that 9 minus 4 is equal to 5 units. So this length is 1, 2, 3, 4, 5 units. So it slides down here. And the slope then is how much is this line changing in the vertical direction for its change in the horizontal direction. Well, if you read these as fifths, 1/5, 2/5, 3/5, 4/5, 5/5, because it's 5 units long, then this length is 4/5 of these 5 units. This is 1/5, 2/5, 3/5, 4/5. So that slope, the change in the vertical direction, is 4/5 of the change in the horizontal direction. So you can think of this as 4/5 for every unit in the horizontal direction. So right here, 1 unit along the x-axis, 4/5 of a unit along the y-axis. 1 unit, 4/5 of a unit. Or you can read it as for 5 units, 1, 2, 3, 4, 5, for both of them, 1, 2, 3, 4, 5, there's a 4 unit change in the vertical direction. 1, 2, 3, 4. It's the same out here. 1, 2, 3, 4. So the slope is 4/5 for both lines. So A is a graph of a proportional relationship because it goes through the origin. So what that means is that 4/5 is the constant of proportionality, and for every value of x that you choose, y is 4/5 of that value. So for every value of x that I choose, 2, y is going to be 4/5 of 2. 3, y is going to be 4/5 of 3. 5, y is going to be 4/5 of 5, or in this case, 4. So again, this is a proportional relationship. Y is 4/5 of the value of x every single time. B is a graph of a linear relationship, but it is not proportional. You always have to adjust for this -3 2/10 along the y-axis, or the vertical length. So this is the proportional part right here. Y is equal to 4/5 of x, the same as A, but then you have to subtract 3 2/10. So this is adding a -3 2/10 or subtracting 3 2/10. It's like having a discount coupon for $3.20. So whatever you purchase, you have to subtract $3.20 from that purchase. So you go out here, your purchase is, say, $4, but then you have to subtract $3.20. So this would be the amount that you actually pay, would be right here, or 80 cents. B is where this graph B, crosses the y-axis. It is called the y-intercept. It is this adjustment, this -3 2/10 for whatever value you get for y. So y is 4/5 of whatever I choose for x, but then I have to either add a negative 3 2/10 or subtract 3 2/10. They're both the same thing, and that is b. So when x is 0, b is a negative 3 2/10. That's the value of a discount coupon, for example. So I could just replace b with a negative 3 2/10 and I'd be done. So y equals 4/5 x plus a negative 3 2/10, or y equals 4/5 x minus 3 2/10. They are the same thing. But this is a good time to check your calculation to understand how you calculate what b is. Because we know what b is. We know it's going to be a negative 3 2/10. So let's calculate that and check our calculation. So remember, if I choose 2 points on this line, so 9, 4, and 4, 0, and I calculate the change along the y-axis, or in the vertical direction, for the change along the x-axis, or in the horizontal direction, it will be 4/5. So the slope is 4/5. So what that means is I can replace this point right here, 9, 4, with x and y. So I can choose any point along graph B. And if I subtract 0 from the y-coordinate and 4 from the x-coordinate, so y minus 0 and x minus 4, I'm going to calculate the slope. I'm going to get an answer of 4/5 for whatever point I choose, because that's the slope of the graph. So y over x minus 4, so this is y minus 0, so y, this is the x minus 4, that equals 4/5. It is that has that relationship of for every 5 units along the x-axis, this graph goes up 4 units along the y-axis, or for every 5 units in the horizontal change, there are 4 units in a vertical change. So another way of looking at this is that the y-coordinate is 4/5 of whatever the x-coordinate is plus negative 4 or minus 4. You have to get rid of these 4 units right here. So y is equal to 4/5 of the x-coordinate with this adjustment of negative 4. Well, you can use the distributive property and figure out that this is 4/5 x, so this is the proportional part once again, but then you have to make this adjustment of a negative 16/5. So 4 times 4 is 16, it's negative, so it's a negative 16/5. Well, negative 16/5 is equal to a negative 32/10. Just multiply by 2 over 2. 2 times 16 is 32, 2 times 5 is 10. So this is negative 32/10. That's that adjustment from graph A, from the proportional part. So you're adding a negative 32/10. This is a negative 32/10, which is the same as a negative 3 2/10. So this is that adjustment, negative 3 2/10, negative 3 2/10. So y is equal to 4/5 x plus a negative 3 2/10. And so B checks. I get the same value. I get this negative 3 2/10 by calculating it up here, replacing one of the coordinates with x and y. So negative 3 2/10, negative 3 2/10, and that is B. So this is the equation for B. Y is equal to 4/5 x plus a negative 3 2/10, or 4/5 x minus 3 2/10. And this is the equation for A. Y is equal to 4/5 x. And notice the relationship. This is the proportional part, and then there's this adjustment of a negative 3 2/10. For whatever value you get for y along this line, along graph A, you then have to adjust that value down 3 2/10 to get to graph B.